This problem is asking us to differentiate, which just means find the derivative of. So differentiate this given equation, and then they always put this with respect to x. That's just kind of telling us the variable that we care about in our problem. So just directions there. So when we're looking at this, we're looking at f of x equals the cosecant of 5x to the fourth plus 3x squared. When you look down on your page and you see a trig function in front of you, really this is, almost always got to flow from that trig function. And so trig functions are what I refer to as special case derivatives. I call them special cases because there's something you just have to have memorized. If you have it memorized, it's not a problem. If you don't have it memorized, you're probably not going to guess it. And so the special case trig function we're looking at on this one is for the cosecant of x. So if f of x equals the cosecant of x, then f prime of x, the derivative of that, is equal to negative cosecant of x times cotangent of x. And whenever you're dealing with these trig functions or any of these special cases, really, the rule always is as soon as that becomes anything more than just your basic x, so as soon as if it becomes 3x, negative x, as soon as it is more than just x, it's a chain rule problem. So a lot of the trig functions, a lot of the special cases that you run into that I call special cases, they're almost always going to end up in a chain rule problem because very often you're going to be given something more than just an x. And as we look over at this problem, we can definitely see that inside our cosecant is something way more than just an x. And so that tells us that we're going to need to apply our chain rule. So for me, I have a little chain rule saying a little chain rule recipe that I use. My chain rule recipe goes d in times d out. Your teacher is probably going to use something different than that. It works for me and it works really simply and easily and I can spew it out of my brain. So, whatever you need to memorize to make sure you get the chain rule right, but I really recommend this saying here. So d in meaning the derivative of the inside piece and d out meaning the derivative of the outside piece. So when I come to apply that chain rule to this problem, the inside piece is going to be whatever replaced that basic x in my special case there. So our inside piece in this is that 5x to the fourth plus 3x squared. So the in is 5x to the fourth plus 3x squared. We need to find the d in, the derivative of that. So the derivative of the inside piece. Looking at just this one little chunk here and saying, how would I take the derivative of that? Well, that's just a bunch of stuff being added and subtracted. And so that's just going to be a power rule. Everything seems to always flow back through the power rule at some point. The power rule, remember, just is our basic rule. It says bring the power down and then subtract 1 from the power. So applying the power rule here, we bring that 4 down. 4 times 5 gets us 20x. Subtract 1 from the power gets us x to the third. Doing the same thing on the next piece. Bring the 2 down. 2 times 3 is going to get us positive 6x. Subtracting 1 from the power would get us x to the first. Now as I come to look at the outside piece is my cosecant function. So this is the piece that is going to follow this special case rule. The derivative of cosecant is negative cosecant cotangent. And so why I leave these parentheses here is because what's inside those parentheses stays the same. It's your in, untouched. Whatever's inside there stays the same. And it's the same in both chunks when we get these negative cosecant cotangents. So that inside piece stays the same. So when we're looking at the derivative of the outside on a trig function, you're really looking at your special case, following that, and then replacing those x's with whatever was inside there. Now that I have both of my pieces, my ingredients as I like to call them, I am ready to follow my chain rule recipe to get my final answer for the derivative. So my final answer for the derivative is going to be f prime of x equals d in. So we go grab the derivative of the inside. 20x to the third plus 6x. And then we're going to multiply that by the derivative of the outside. So make sure you put this stuff in parentheses, especially when you've got a negative sign, like a negative cosecant or a negative cosine on your derivative. They will happily read that as a subtraction sign if you don't make sure you put the parentheses to remind them that what's happening is these two things are being multiplied. So parentheses, negative cosecant, and then leave all that junk alone, cotangent, and leave all that junk alone you already took the derivative of. Put your parentheses on and walk away. That's your derivative. On these special cases, they almost always turn into a chain rule, and it's the derivative of the inside times the derivative of the outside, and walk away. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.